Hey everybody, this is Larry. It is day, I think 27, if I said it wrong, after the Leetcode Day challenge in September. It is September, right? I have no clue what am I doing anymore. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's vlog. Let's go. Hey everybody, this is Larry. I guess I have the intro, so I don't know. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about it. Today I did 11 miles, 9 miles hard, so I'm just very drained. I don't know what people do after the marathon, honestly. I haven't really thought about it because I was just thinking about running the actual marathon. But and the tricky thing is that it's going to be in DC, in Arlington, that area. It's tricky because I don't know, like I just want to pass out for like 20 hours afterwards, I think. But I have to get home, so we'll see what happens. Because if I feel this tired on a normal whatever day, I don't know what I'm gonna do on a marathon. But yeah, we'll see how it goes. Anyway, do I have multiple windows up? Yeah, wow. Luckily I caught it a little bit earlier. Hang on, let me. Let me change the window real quick. Because yeah, wow. I counted too. Okay. Wow, yeah, because I was clicking on things and I would have, gone on starting it without it. My apologies, I'm a little bit slow. All my energy is, I don't know. I did eat, but I don't know, it's just not quite, I don't know, I'm a little bit off. Thursdays are usually my hardest day in training for whatever reason. And today the humidity was 90% at 70 degrees Fahrenheit, which is about 22 degrees Celsius. Not super hot, but 70 or 75 actually. 70 is what it is now. And 75 is like what, 23, 24 degrees Celsius with 90 degrees humidity. So I was just dying. But I'm always proud afterwards, so that's why I'm bragging here. Nah, I mean I don't go fast enough to brag. But in any case, yeah, let's take a look at today's problem. But I'm just setting up an excuse for when I make silly mistakes. But today we have 731, my calendar 2. Yeah. If you are implementing a program to use as your calendar, we can add a new event if adding the event does not cause a triple booking. Okay, so the same as yesterday, except for now. Well, I mean, I guess I have to finish reading. So let me finish reading first, just in case. Triple booking when 3 events have some non-empty thing. Some moment is common to all 3. Okay. The event can be represented by a pair of start and So this seems to be exactly the same as yesterday, except for now instead of 2 things overlap, 3 things have to overlap for it to return false, right? And the constraints are the same. I honestly I don't really have. I mean I don't really know anything specifically off my head, to be honest. I mean, other than maybe playing around with same ideas that we have yesterday. So I'm going to bring up the drawing board. Hang on. And I'm not going to lie. Right now, I don't know what the answer is, right? So how do we want to represent this data, right? So, okay. So let's say we... how am I attacking this? I need to draw straighter lines. All right, let's just do the straight line too. But, okay. So, the first one will always be good, and even the second one will always be good. So we have someone like this we don't ever have to care about. So only cases, let's say that we have overlaps, right? So maybe we have someone like this, and then now we have to add another one, which is, okay. So then now let's say we have someone like this, then what happens? Right? Well, here we have 4 endpoints, and 4 endpoints is kind of like a pigeonhole thing, right? So, because you know that with 4 endpoints, it has at least 2 things. So then maybe I can brute force some, or not brute force, but iteration, right? So in this case, we if we do the same idea we have yesterday, and Also, I'm skipping a little bit. If you didn't watch the video yesterday, then definitely watch the video yesterday, because yesterday's video was on my calendar one, or D calendar one, or whatever it's called. And I think I go over what I do. I'm doing the same thing as I did yesterday, but now I'm going to cases. So if you're not understanding what I'm doing, then that's basically, I would recommend watching the video for that reason. Okay, so here this is easy, right? Easy-ish, because we have 4 things inside. So that means that we're always going to do the pigeonhole, because it's either this or you have like, is it true? No, I'm wrong, right? That's not true, because we could have something like this, right? And that has 4 things inside. But I think if it has 4 things inside, right, then we can just walk it, because if we walk, then it does at least at most 4 things, right? If we do a walk and we only look at 4 indexes, it's not a big deal, right? And I guess if you're going to do that for 4, you're going to do that for anything less than 4. So you could just walk it, anything, right? And then what is the biggest amount where, okay, so then now, okay, yeah. So if it's 4, we can walk it, say, and I don't have, I know that this video is probably going to be a little bit disjointed, because I don't know the answer yet, honestly. So I'm still trying to figure it out. But that's the thing, is that, okay, well, if we're just going to generalize it to here, then that's good. Or like, you know, it's 4 and that's fine. But what if we have a lot of things, right? I think that's the thing, that we cannot walk it. Oh, wait. I think I'm a little bit... I think the tricky thing is that that I'm just remembering about this part, or the constraint is that at most 1,000 cores. If we do it at most 1,000 cores, then we can just actually just like yeah, we're gonna do at most 1,000 cores, then we can definitely just look at all of them, right? I mean, yes, but that, yeah. Because the thing is that, okay, let's say it's more, not more than 4. Oops. You can have just like a lot of these, right? So there's really, and I don't know that there is definitely a way to like, you know, to kind of take that into good use. I think one thing that we may be able to do, I mean, if n squared is not fast enough, though, if we're going to put it in a sorted tree data structure, is actually going to be n squared log n, which is maybe a little bit too slow. But in any case, I think the idea then maybe is that we keep track of things that are intersected, right? Because we only add, we don't subtract. So then now maybe we just have to do one extra layer. Is that, okay, let's say we have a bunch of these things. Let's say we have now, like, do something here like this. Well, now we could calculate this intersection. So then now we have this intersection and then this intersection, right? So that, but that doesn't, I mean, yes, and then like when you add, you can just see if you do anything that combines of 2, but that's fine. But then now, what if I have something like this, right? Let's say I add something like this, which is legit because it has at most 2 things. But then now your intersection things look like this, and then now you're just doing a lot of things, right? Which is also going to be n squared log n in the aggregate. So it's not like like it does help, maybe, but it's not enough. N squared log n. 1,000 log n is it's 10, right? 1024, so 10. 10 million. Honestly, with Leetcode, you never know if it's going to be fast enough with 10 million, which is why I'm hesitating. Because, I mean, I'm a little bit tired to explain it, but basically Leetcode does a thing called sum of execution time, and basically your test cases, they just sum over all the things. So even if you put in a max case and it runs fast enough, you don't know if it's going to be fast enough, because they may do 1 max case or they may do 10 max case, and they have different outcomes, right? or even like 100 max case say. So I'm looking for my other pen. Okay. So I don't know. I'm trying to think. Okay. Well, in any case, then how can we think about how else can we think about this? I mean, maybe we could do a segment tree. I think that's a little bit crazy. I don't know. I'm not gonna think about it that much though. I mean, maybe, but I don't know if you can. I'm just okay. What else can I do? Assuming that this isn't the n square log n thing. I'm just looking at this. Oh, I'm not showing it. Right now, I'm just looking at the test case just in case. 10 to the 9 means that, again, we cannot do coordinate compression. And we have to do some live query thing. Is there a way to do some intersection things? Maybe not. With coordinate compression, it would be pretty good. I think that'll be fast, but we can't really do it. Not easily anyway. I think one thing that I think what I was trying to do is, I think I'm trying to do a bisection to, or like a binary search to kind of speed this up to get the left range, right range, but then we're just going to get it anyway. Or like, but then like the range could be so big that you're going to look at everything anyway. So I think one thing that I did forget about, and because of that, that is actually n square log n, but we can actually do it without the binary search. So then now the things we insert may just not be ordered. I think maybe that's the way to do it. We just have to keep track of things, and we just have to look at everything every time. So then in that case, it'll be just n squared instead of n squared log n, which should be fast enough for n is equal to 1,000, right? So here maybe we could do like, what's it, segments, right? Do we want to do like the 2 segment thing? I guess so. Let's try it. Terrible naming. But yeah, here. So then if it overlaps with things with 2 segments, and basically what I'm doing here is what I kind of wish mentioned earlier with having we could create a segment of things that overlap, right? So that should be good, right? So here, so for SE, just do it left, right, in self.segments 2, and what we are doing open close, oh sorry, close open, half open, right? So that means that if left is in between, yeah, return false if it is something like this, right? I mean, I think there's like 4 ways to write it or something. right? And then now that means that, yeah, then we're good. We're gonna see, check things that overlap with one, right? If it overlaps with one thing, then it goes to the two segment thing, right? Yeah, for left, right in sub.segments. Right. So then, what are the things? So I think it. Honestly, some of it is just by muscle memory, but I should probably draw it out. And drawing out is not that bad. There are only 4 cases, right? So maybe I'll bring it up real quick, just so that I don't make silly mistakes. And then like people are like, "What, Larry? How does this formula work?" And I'm like, "I don't know. I just kind of write it." But yeah, but basically here, okay. So let's say 2 things overlap. So you have this case. You have the reverse of it, symmetry. So and then you just have like this, right? And then maybe this, if you record. Okay, so then now, yeah, so the intersection is going to be, oops, let me just use a different color real quick. The intersection is going to be, this one's going to be here, here, and here, right? And it's basically going to be the max of the starting points, and then the min of the ending points in both cases, right? So I think that's basically the thing. Yeah, right. Except for, well, I guess right is open anyway, so I think that's fine. So then now we have, okay, so left is equal to max of left start, or is equal to min of right n, and then it is if left is less than or equal, is it equal to? I guess if it's equal to, then it doesn't make sense, right? It's just like yeah, if it's strictly, then we can just put it in self.segments2 dot append lr, right? So that's intersected segment. Yeah, and it doesn't change anything either way. So then now we just add it to segments 1, or I just, yeah, whatever at this point, start n, and then we return true. So this should be n square. I'll try to make n log n work, but I guess, I think I just get, I think it is one of those things where you remember it from the, I just want to double check that I removed the screen, because sometimes I'm blocking things. But yeah, I think the hard part about this is just that we were thinking about the first version of this yesterday, My Calendar 1, and it is very easy to kind of get stuck on that sorted list or binary search idea. And I was certainly kind of got stuck on it for a second, but then this is n squared and should be fast enough. But it is not correct enough, so we'll see. What is it? Okay, so I think I return false here instead of true. The event can be booked as it does not use 10, which is already doubly booked. So 5, 10. I think it could also just like, have to, I mean, I don't know how much of a good optimization this is. We can also just like, do this and then see how many things it overlap with, but in any case. Okay, so this is returning false here, 5, 10. It, or maybe we just print what segment 2 segment is. Let's actually also do start and so we can kind of see it together. Okay, so 5 and 10. Okay, 10, 20. All right, so 10, 20. It overlaps with 1040, so that's why we have 1020. Okay, 510, it looks good, doesn't break, and then this now it returns, I guess this returns false, which is why we get false. Why? Because 10 intersects this. Oh, so this is, so the right side is wrong because right is the opening. do I need this? I'm not, honestly, I'm not super used to having a half open one here. That's why and yesterday I did a hack, and maybe we could do it again, but I just want to think about how that works. Or like I want to think through how that works so that in the future I don't have to, right? Because it is just something that I think I'm just not as practiced on recently. So basically we're saying that the n, but has to be this maybe for the right side. Is that enough? And can, or like, is this excessive as well? Because in this case, because in this, or like, I'm trying to, I mean, this may be right anyway, but I'm trying to think where, like, is this case necessary, right? Because there are only two cases, right? There's only, so start is less than left is one case, or maybe even equal to. In that case, then now in that case this is true and we would have returned false anyway. So then the other case is left is, let's say, start, but in this case then this is going to be true, so this is never needed, right? So what I want to try is all right, let me just submit it once, and this is how you, I want to say that this is how you learn for the future when you talk about practice and how like some people are so fast at certain stuff. It's because they've done it on the, they spend the time on the training so that they don't have to do it during the contest, right? Let's give a submit. Okay, so we're good, and this is going to be n squared kind of, if you want to, depending on how you want to say it. This function costs O over n, so yeah, and that's, and we call it n times, I suppose. One thing that I want to see is that, okay, do we ever call these? I want to say it doesn't, because I think these two overshadows it, which is why I'm curious. Because then now, yeah, that's good. Because then now in the future we can just remove these instead of trying to figure out how to, you know. And this is how you deal with open range, which is kind of cool and interesting. Yeah, and you can, and it's a little bit faster because then you just, yeah, it's a free if statement, right? But I think another thing that I'm curious is that do I need a segment too? I mean, I kind of did it this way because we talked about it, but because I was thinking about it, doing it with the binary search, but it didn't need it. But here maybe we can just do something like this, right? Do I need it? We'll see. So then now, if I mean, and this is basically the same idea as before. Maybe you could, if you want to write it this way, then maybe this is, you know, maybe this is fine too, right? Right, and maybe contain you just in case, so we don't. I don't know. This I'm not sure that. I think this does double count though, but otherwise, yeah. Right, and this is much easier if greater return false. Otherwise, we just add it, right? Oh, that's not true. This is wrong. It has to be. Oh, yeah, this doesn't work, right? Because then now, like, it just doesn't work, right? Because it can overlap multiple segments in different places. I think I'm just being dumb. And the thing is that one way to get around that is by doing like a sweep, but in sweep, then now you have to keep it sorted, and keeping sorted now brings it back to n square thing. So okay, now I don't think, I mean, I think we need it, or at least I don't know an easy way of doing it without it. Maybe I could have just done it before writing this a little bit. In any case, yeah. That is all I have for this one, including the random extra bonus exploration. Yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.